Okay, so these instructions say sketch the graph of each function and then describe the end behavior of each function. It says using interval notation, but I'm going to work with just the notation our book used. With the x goes to, when x goes to positive infinity, what does y do, right? When x goes to negative infinity, what does y do? Okay, so let's start with this. So I'm going to use my graphing calculator to do that. I'm going to go ahead and I'm going to say, though, just looking at this, I can tell that because this has an odd exponent here, a degree that's odd, I know that it's going to look something, and then because it's got a positive leading coefficient, I know that the graph is going to look something like this. The end behavior is going to be something like this. So I can actually describe the end behavior before I even put it in the calculator. But let's just do a double check since I'm going to x to the third minus 4x squared plus 7, right? So I'm going to look at, and remember I used my window, a different window last time, so I'll just go back to negative 10 and 10. Okay, so I can see pretty clearly here what it does, but I'm going to get a better sketch if I have actually points to use. So like negative 1, positive 2 is a point, 0 and 7 is a point, 1 and 4 is a point, 2 and negative 1 is a point, 3, negative 2, 4, positive 7, so we're going back up, right? 4, positive 7, and then 5 goes. So this way, this kind of gives me the shape of the, like, where it goes up, where it goes down, where it goes back up again, right? So there's a general sketch of the graph going through some important points, right? Okay, so describing the end behavior. So see how I knew what the end behavior was? It's going to go down here and up there, even though I didn't really know what the middle looked like. So this leading term gives a lot of clues about the end, doesn't give a lot of clues about in here. I didn't know whether it was going to be flat or kind of up and down a lot. But the end behavior was what's important. So remember when you're talking about end behavior going this way, we're saying x goes to negative infinity, right? As x goes down, as you go to the left, x goes to negative infinity, y also goes to negative infinity. We also go down. So as we go to the left, our y values go down. And then as x goes to positive infinity, y also goes to positive infinity. It goes up. So as I go to the right, I go up. So if you had written, as I go to the left, y goes down. As I go to the right, y goes up. That would have been correct English way to say that. And this is the correct math notation to say that. As I go to the left, y goes down. As I go to the right, y goes up. So you do the same thing for these problems.